time. Dear listeners, welcome to another video focused on chemical calculations. My name is Pavlína Marvanová, and this time we are briefly going through the calculations from a chemical formula. Let's return for a while to the quantity called the mass fraction. We already know what is it from the previous video. It is the ratio of the mass of any component and the mass of the whole. We will use it also in this type of calculations. We have two types of calculations from a chemical formula. Either we have the chemical formula of a compound and we want to find out the percentage of the individual elements, or conversely, we have the percentage of the individual elements in an unknown compound and we have to find the chemical formula. If we want to determine the percentage of elements in any known compound, we will proceed as follows. For the calculation, we have to create the mass fractions for all individual elements. Let's start with the element A. We know that the mass fraction of the element in the compound can be calculated as the ratio of its mass and the mass of the whole compound. If we don't know the specific mass of either the element or the compound, we can help ourselves in this way. What we always know is the relative mass of each element, and we are also able to calculate the relative mass of the compound. Remember the first video, when we introduced the quantities atomic and molecular relative masses. The mass fraction for element A will look like this. In the chemical formula, X is the coefficient that tells us how many times the element A is present in a compound. Then, for the calculation, in the fraction it will look like this. In the dividend, there is an atomic relative mass of the element A multiplied by the coefficient X, and in the divisor, there is the molecular relative mass of the whole compound. In the same way, we'll set the fraction for the other elements. The atomic relative mass of the element B multiplied by the coefficient Y divided by the molecular relative mass of the whole compound. The atomic relative mass of the element C multiplied by the coefficient Z divided by the molecular relative mass of the whole compound. To check that our calculations are right, the sum of all three mass fractions have to be 1 or a number very close to 1 because of the rounding. Let's try with a specific problem. What is the percentage of iron in ferrous carbonate? The first step that is crucial is to write the chemical formula for ferrous carbonate correctly. This is important because we need to calculate the molecular relative mass of the whole compound correctly. We will calculate it from the atomic relative masses of the individual elements. If we make a mistake already here, then our calculations cannot be correct. Our task is to calculate the percentage of iron. Let's set the fraction. In the dividend, there is the atomic relative mass of iron multiplied by the coefficient 1, because there is only one iron atom in one molecule of ferrous carbonate. In the divisor, there is the molecular relative mass of the ferrous carbonate. We will get the mass fraction for iron 0.482. Because we are asked for percentage, we will multiply it by 100 and get the content of iron in the ferrous carbonate 48.2%. Although the task was only the calculation for iron, let's calculate the other elements too. Carbon is calculated in the same way, as the carbon coefficient in ferrous carbonate is also 1. Numerically, we will get the mass fraction 0.103, which is converted to a percentage 10.3%. For oxygen, we have a coefficient 3, so we will multiply the atomic relative mass of oxygen 3 times and then divide by the molecular relative mass of ferrous carbonate. We'll get the mass fraction 0.5 414, which is converted to a percentage, 41.4%. For the control, as we have said, the sum of all mass percentage of all elements should be 100%. And we have together 99.9%, which is very close. So we have calculated correctly. Now our task will be the opposite. What is the stoichiometric formula of the oxide, which according to the analysis contains 72.36% of iron and 27.64% of oxygen? The individual elements are given, so we know that it will be the iron oxide. And our task is to find out just the XY coefficients. There is an existing procedure how to deal with such calculations. We will calculate the coefficient for iron by taking the value of the percentage of the iron content, and this value we will divide by the atomic relative mass of iron. Numerically, 72.36 will divide by 55.85. We will get a coefficient of 1.29. We will do exactly the same for oxygen. We will again take the percentage value of oxygen content in the compound and divide by the atomic relative mass of oxygen. Numerically, we get a coefficient 1.73. Those coefficients are not satisfying for us because we prefer using the integer to the decimal in the chemical formulas. We will take the smaller one from all the coefficients we have calculated, and with this value, we'll divide all of the coefficients. In this case, we will take the value 1.29, which we calculated for iron, and we will divide by it the value calculated for iron and the value calculated for oxygen. After that, we will get the coefficient 1 for the iron, and for oxygen, we'll get the coefficient 1.33. This is better, but we have an integer for one element, which is still not enough. Step 2 is to find a number to multiply these second coefficients to get an integer for all elements. Let's look at it. If we multiply both values by 1, we will get the same values. If we multiply both values by 2, we still won't get the integer for oxygen. We will get 2.66. But by multiplying by 3, we will get a coefficient 3 for iron and 3.99, which is very close to 4 for oxygen. By using these coefficients in the formula, we will obtain an iron oxide Fe3O4. This compound is a mixed iron oxide, ferrous ferric oxide, also known as the magnetite mineral. In this short video, we have shown how to calculate from chemical formulas. I have mentioned that there are two different types of calculation, and I have shown you a procedure for each of them to deal with them. Thank you for your attention.